Natural radiation accounts for most of the radiation exposure of almost everybody in the population. And there are various sources of it. The two that are fairly easy to measure and it's easy to get individual variations on are exposures to a natural radioactive gas called radon and the terrestrial gamma rays, which you measure together with part of the cosmic rays, the bits of the cosmic rays that are directly ionizing. Then there are other parts of the natural radiation exposure, like radionuclides in food, where it's almost impossible to get individual estimates. We know that childhood leukemia is caused by radiation. There's evidence from the atomic bomb survivors and from people exposed for medical reasons. But those are reasonably high doses and then occurred very quickly. And the question that we were trying to address is whether there were also effects from really very low doses of radiation incurred very slowly, to be precise, from the natural background radiation. So what we did was took a very large number of cases, about 27,000 cases of childhood cancer, and a slightly bigger number of children who were otherwise similar but didn't get cancer. So it's what's called a case control study. And we compared the radiation exposure in the cases with those in the controls. And the two types of radiation exposure we were looking at were the gamma rays and radon. Normally, when you do a case control study, it's what's called interview-based, which means that you go and you interview the parents of the cases and you interview the parents of the controls and you make measurements of radiation levels in their homes. The difficulty with that is, firstly, that it's expensive, and in the case of this kind of study, it's almost prohibitively expensive because you need tens of thousands of cases and a similar number of controls. And also, and this is a bit more subtle, the problem is that the response rate is not uniform. Different kinds of people respond in different ways. And what's particularly troublesome is that the better off people actually tend to have slightly higher levels of leukemia, and they also tend to have slightly higher levels of radon in their homes, probably because their homes are a bit warmer and this generates under pressure and sucks in radon from the subsoil gas. And if you have differential failure to recruit people across the socioeconomic statuses, then you are running a risk of getting results that are really just driven by SES and not by radiation at all. So the study that we've done is not interview-based, it's record-based, which means that we can take every case of childhood cancer that there was in the United Kingdom between 1980 and 2006, and we don't lose anybody, so there's firstly the study is very big, we don't lose anybody, so there's no participation bias. The problem is, of course, that we don't have the measurements of radiation exposures, so we have to estimate them in some other way. And we were fortunate because for radon there's a lot of work being done on predicting where radon levels are high, and this is based on a huge number of measurements, about 400,000 measurements, plus a good deal of information on geology, and they put the two together and produced a predictive radon map. For gamma rays, it's not quite so easy. We had a national survey which had made measurements in about 2,300 houses across Great Britain, and we used these to estimate the mean gamma ray dose rate in county districts, which are administrative units. So where I live, it's the county district of Oxford City, and within Oxfordshire there are another 4 county districts or something. So our estimate for gamma rays was the mean for the county district. And when we analysed our data, what we found was that we analysed in terms of leukaemia and all other cancers. And in fact, we looked at the breakdown of all the cancers to see if there was any sore thumb in there, and there wasn't. So our basic analysis was breaking down leukemia and other cancers. And when we did those analyses for radon, we couldn't see anything, neither for leukemia nor for the other cancers. The relative risks, which are an estimate of whether there is an association or not, relative risks above 1 means there are, and relative risk below 1 means that it might be protective. The relative risks were above 1, but they were only a little bit above 1, and they weren't close to statistical significance. When we looked at gamma rays for cancers other than leukemia, the picture was the same. The relative risk was up a bit, but not very much. And when we looked at leukemia, it was different because the relative risk was increased and there was only 1 chance in 100 that was a statistical fluctuation. And we analysed our data in all kinds of ways. We looked at different measures of radon. We looked at different ways of accounting for socioeconomic status. We looked at different exposure periods, and we always got the same broad kind of association. And we believe that what we found is a genuine association between childhood leukemia and gamma rays, natural gamma rays. People shouldn't get too worried about it because we calculate that all the natural radiation accounts for only 15 or 20% of childhood cancers, and the natural gamma rays are half of that or a bit less. So it's not a big risk, and the risk actually is entirely consistent with what you get by extrapolating from the very high dose risks from the atomic bomb survivors down to these very low doses that we've got.